In this part, I show you another way to create your own user-defined or custom-built data type. And this part deals with structures. So let's take an example. In the previous module on hardware, we said that all screens, iPad or iPhones, have a resolution which consists of the number of pixels along its width and the number of pixels along its height. So here I'm going to create a structure that's going to store these two values, the width, number of pixels on the width, and the number of pixels on the height, and I'm going to encapsulate these two properties or variables in a structure called resolution. So here I'm creating a structure called resolution with the keyword struct, capital letter resolution, and this structure is a very simple structure. It just has two properties, and the two properties are a variable property called width and a variable property called height, and I'm initializing it to 1920 and 1080. This could be any value, but in this instance it's the number of pixels on a particular resolution of a screen. Once your structure is created, you then need to create instances of that structure. And this is how we create instances. You could create variable instances, or you could create constant instances of your structure. Here I'm creating a constant instance of my structure called HD TV. I have a high definition TV at home and I want to make it of type structure resolution. And you'll notice open bracket, close bracket, I'm not passing any parameters to the structure because I wanted to take the default values, which is 1920 and 1080. So here I'm creating an instance of a structure and I'm defining of what type this instance is, of type structure called resolution. And you'll see here that it's initialized with, the properties are initialized with the default values that were given in the definition of the structure. Here I'm creating a variable instance of that structure called VGA, and I'm giving in my own default values, 640 and 480. I don't want it to use the initial values that I defined. I want to give it my custom built custom values of width and height. For those of you that are old enough, you'll remember that in the old days we did not have HD TVs. We had VGA TVs with very low resolution, and it had 640 pixels by 480 pixels. Once you've defined your instances and set their initial parameter properties, you then can use them to change the value of the property or even output a property value. Here I'm outputting the property width of this instance of a structure called VGA. Here, no, sorry, I am changing the value of width. I'm putting a new value of width of 1024 into this property called width of this instance of a structure called VGA. And here I'm outputting the value of width of this instance of a structure called HDTV, and the width is 1920. So we have created a simple structure called resolution, but structures can be more involved or complicated. I now want to show you how we can create a structure that consists of both properties and methods. Similar to classes that have properties and methods, structures can also have properties and methods. So let's take an example. Let's take a math example. I have a triangle and it has a base and a height. So I can define two properties, variable properties called base and height, and of type double. But why would we want to define a base and a height? We'd want to do some calculation on the base and height. And one of the calculations that we can do on a triangle is to find out what the area is of the triangle given the base and height. One of the formulas for the area of a triangle is half base times height. So here I'm defining a method called area that does not take in any input parameters, but it will use the properties in the body of the method to calculate what the area is using the formula half base times height, and it will return the area. So what I've done is I've encapsulated the base and height being the properties and the function or method called area into a structure called triangle. Once we've created the structure, let's create an instance of that structure. So here I'm creating an instance of the structure called some triangle of that structure type called triangle, and I'm giving it the initial values of base 4 and height of 12. Then I'm calling this method called area of this instance called some triangle. It's not going to pass any parameters. It's going to use the properties to 4 and height of 12, half base, which is 12, times the height, half base, which is 2, times the height, which is 12, will give me the answer of 24. Looks very similar to a class, okay? But there are some differences between structures and classes. So as I said, in this part, we dealt with structures, and you see structures have both methods and they have properties. They use all the same terminology as an object. They also use the terminology called instances. So on the surface, there may be some similarities between these structures and classes, but there are also some differences. So in the next part of this lesson, I'm going to spend some time in detail to tell you what is the difference between structures and classes. What are some of the similarities between structures and classes? When to use structures and when is it appropriate to use classes? So that as a programmer, you will know, that these two data types, custom data types do exist, structures and classes, but when is it appropriate to use which user-defined data type?